Good morning to everyone. So all of you can able to hear my voice?
Yes, sir. Good morning.
Good morning. Okay. The last class we have discussed about what is a BCD adder. Okay. Do you have any queries in the BCD adder? How we are going to draw the circuit diagram for BCD adder? Do you have any queries? I'm going to provide some overview about BCD adder. What is how it going to perform BCD addition? So you are going to perform addition. Okay, you are going to perform addition of two numbers, and then it's going to produce a result. If the resultant values, if the resultant values less than or equal to 9 means no problem, no problem. Okay, no problem. When the resultant values, when the resultant values greater than or equal to 10, greater than or equal to 10 in the sense, along with the result, along with the result, you're going to add the correction bit. That correction bit value is nothing but 6. This is a binary representation of 6. Okay. So whenever we are going to form designing the, whenever we are going to designing BCD error circuit, okay, what are the parameters I'm going to consider means, first one is binary sum, binary sum. Another one is BCD sum. The last thing is an respective decimal representation. Okay. So what happened? I will list out up to 19. Up to 19, what happened? I'm going to represent the binary sum as well as BCD sum. So if we do that, what happened? Up to 9, there is no problem for BCD sum as well as binary sum. Up to 9, there is no problem for BCD sum as well as binary sum. Here, how I'm going to take the weightage means already you know that each bit is associated with certain weightage. So based on that, what happened? I'm going to take it 8. This is 8. Similarly, here also. Okay. Is it 1, 2, is it 4, is it 8? Instead of here, what happened? You take any variable. Okay, no problem. So like that, what happened? I'm going to take that. So whenever the output value is greater than or equal to 10, what happened? Okay, along with the result, what happened? You want to add the correction bit. Then only what happened? You're going to produce a correct output. Okay. If you look at that correct output, what happened? Okay, if you look at that output, what happened? If you look at that output, what happened? Suppose if you look at that, what happened? The C bit, what happened? Okay, for what I'm trying to say that the output value is greater than or equal to 10 means what you're going to do, you're going to add the correction bit. The correction bit value is 0, 110. Then only what happens, it's going to produce a correct output or otherwise called as a correct result. If you look at that after correction, if you look at that output, what happened? The most significant bit always containing 1. The rest of the bit, whatever it may be, the most significant bit values always what happened? 1. So I'm going to consider that factor. So based on that, what happened? I'm going to design BCD adder circuit. Okay. So I'm going to consider this factor. So what do you understand from this in the sense? So after making the correction, what happened? There must be bit 1. So based on that, what happened? I'm going to design the circuit. So now what I did is this is the output. So based on that, what happened? I'm going to take the respective input combination. So for that, what I did is I'm going to draw the, I'm going to find out the Boolean expression for the that C. Okay. So do you have any queries regarding this? Do you have any queries?
No, sir.
Okay. So whenever we are going to perform BCD addition, we had two binary adder. So I will tell you what's the need of two binary adder. One for we are going to add two binary adder. Okay, binary adder. Okay, one for binary adder. What is the input for binary adder means? Okay, weightage 4, 8, and so on. Okay. After that, what happen? I am going to add one more binary adder. So, what is the necessity of the binary adder means? What is the necessity of that binary adder means? For example, your result, the resultant value less than or equal to 9 means no problem. So, what it going to generate? That is a output. Okay. Suppose the resultant values greater than or equal to 10 means what happened? Okay, along with the result, okay, you're going to add the correction bit. Okay, that is called as a 6. Okay, what is the necessity of that first adder means if the resultant value less than or equal to 9, there is no problem. You record only one adder. Suppose the resultant value is greater than or equal to 10 means what happened? First of all, you're going to generate the result and then you're going to check it. So in order to generate the result, what happened? You needed one adder. Okay, you required one BCD adder. Okay, it's required one binary adder. It's required one binary adder. So after that, what happened? You're going to check that. If the resultant value is greater than or equal to 10 means what happened? You're going to add the correction bit. So in order to perform the correction operation, okay, you require one more binary adder. Binary adder. That's why what happened in the BCD circuit, if you consider any BCD circuit, it totally it's required to bind two binary adder. Okay, totally it's required two binary adder. Okay, here what happened? We are going to here what are the components are available means the correction circuit implementation is there. Here correction circuit implementation is there. Okay. Okay, I hope that all of you understood. That's why I forward to next concept that is called as a code conversion technique. Okay. So what is the meaning of code conversion? Okay. What happened? I'm having one binary code. The binary code, what I'm going to do, I'm going to convert it as a gray code conversion. That is one type of code conversion. Similarly, what happened? You had okay, you had binary code. You want to convert it as a decimal. That is a one type of code conversion. Okay. The next topic is the code conversion. The code conversion, what are the things we are going to discuss that in the sense? First topic is, okay, how do you convert the gray code values? How do you convert the gray code number into binary code? Okay, and second thing is reverse order, vice versa. I am taking input as a binary coded number, binary code number. You want to convert it as a again return. How do you convert return back to gray code? Okay, okay. So let we discuss about one by one. Okay, first we talk about. I am taking input as a gray code. I am taking input as a gray code. Okay, you want to convert. What is the output means? You want to convert it as a binary representation. Binary representation. Binary code. So for that, what I'm going to do, I'm taking the one gray code number that is called as a G. Okay, it associated with the 3 bits. In that it associated with the 3 bits that can be represented as a like that. Okay, how do you convert it as a Grade 2 binary means, okay, that's a procedure. Okay, for example, okay, if you convert it as a binary code, what is the first output? The first output is called as a B2 because this is my input is 3-bit variable. So the output, what happened? The output also what happened? 3-bit variable. The first output is called as a B2. So how I am going to generate the B2 means, what is the value of G2? That is called as a B2. So what about B1 means? B1 means B2 exclusive OR of G1. B2 exclusive OR of G1. So what about B0 means? Okay, how do you generate the B0 means? Okay, B1, okay, B1 exclusive OR of G0. Okay, if you do that, what happen? Okay, you can final output is called as a binary coded value. Okay, what happened? The here, how do you do that in the sense? Okay, what is the value of G2? That is the value of B2. Okay, next, how do you find out the B1 value means? You are going to add the resultant of B2 along with the G1. Okay, what operation you are going to carry on means exclusive OR. Okay, exclusive OR you are going to perform. The final output is called as a, okay, the G2 otherwise called as a B2. Okay, if you do that, what happen? You will get the output is called as a B1. Okay, after that, what happen? Again, you take the resultant value added with, okay, G naught. You're going to apply exclusive OR operation. Okay, you will get B naught. So this is a way what happened. We have converted gray code value into binary. Okay, in order to understand that, I'm going to take one example. I will work it out. Okay, I'm going to take one example. Okay, this is an example. They given one 3-bit values 1, 0, 0. Okay, this is a given value. It's a gray code. You want to convert it as binary. Okay, how do you do that? Okay, it is associated with the 3 bits. First one G2, sorry, G3, sorry, G2, G1 and G0. Okay, how do you do that? What is the binary value? Okay, the initial value. Okay, what is the, how do you do that? So B2 is nothing but G2 and then B1 is B2 exclusive OR of G1. What about B0? The B0 is B1 exclusive OR of G0. Okay, apply that procedure 1. Okay, now what happens? You are going to perform exclusive OR. What happens, sir? What is the truth table of exclusive OR? If the inputs are different, what happens? Okay, it's going to generate the output equal to 1. The rest of the cases, output equal to 0. Okay, that is a truth table for exclusive OR. Okay, so what do you understand from this means the input are different means it's going to generate the output equal to 1. Okay, again, you're going to perform exclusive OR. What happens? It's going to generate the respective binary value. This is called as a B2. This is called as a B1. This is called as a B0. Okay, do you have any queries? Do you have any queries? Hello?
No, sir. No, sir.
Okay.
No, sir.
So similarly, now what I'm going to do, I'm taking input as a binary value. I will tell you how do you convert it into gray code. Okay. The next one is binary to gray code. Binary to gray code. Okay. For example, I'm taking one value, one binary value. It associated with the 3 bits. Suppose you want to convert it into gray code. How do you do that? So this is a procedure. G2 equal to B2 and then G1 is B2 exclusive OR of B1 and G naught is B1 exclusive OR of B naught. Okay, so I will take one example. We'll take one example and then explain it. Okay, for example, this is a given binary number. Okay, you want to convert into, okay, gray code. Okay, you want to convert into gray code. Okay, how do you do that? This is a binary number. It associated with the 3 bits. Okay, how do you do that? Okay, this is B2, this is a B1, this is a B0. Okay, how do you do that? Okay, first what happened? Okay, you're going to perform. So how do you find out G2? G2 is B2. Okay, no problem. How do you find out the G1? B2 exclusive OR of B1. Okay, okay, both are 1. What happened? If the inputs are similar, what happened? It's going to generate the output equal to 0. Okay, how do you convert it into gray code? Okay, B1 plus B0. Okay, so this is a way what happened. We are going to convert it into gray code value. Okay, do you have any queries?
No, sir.
Okay, so my task is nothing but and now what I'm going to do, I'm taking 3-bit gray code value, and then for that what happen, I'm going to designing the circuit diagram for that code conversion. Okay, my task is nothing but I'm taking input as gray code. I want to convert it as a binary. So for that, what I'm going to do, I'm going to draw the circuit diagram. Okay. So my this is nothing but gray code 2. Now what I'm going to do, I'm taking input as a gray code. Now what is the final output is I'm taking input as a gray code. I want to convert it as a binary coded value. So for that what happened, I'm going to take my input is a gray code. That gray code is associated with the 3 bits. Okay, associated with the 3 bits. Okay, this is my input. So what is the operation I'm going to perform means I want to convert it as binary. The input is a 3-bit values. So output also what happened? It's going to generate output as 3-bit values. Okay. So you are only going to tell the answer. Okay. Already I tell that how do you convert gray code into the binary code? Okay. You are only going to tell the answer. What is the answer for first? This is a 0. This is a 1. This is a 2, 3, 4, 5, 6, and 7. Okay. You are going to tell the answer. What is the answer for first one? What is the answer?
0, 0, 0.
0, 0. Okay. What about second one?
0, 0, 1.
Okay, it's correct. What about next one?
1, 0, 1.
0, 1. Okay.
1.
1. What about next one?
0, 1, 0.
Okay, it's correct. Next one.
1,
1,
1, 0.
1, 1.
It's a 0, sir.
0. Can I check it? 1 da varum paru. Next case the 1, 1, 0 varum paru.
சார் 0 and 0 XR போட்டா 0 தான் சார் 0 தான் சார் வரும்.
0 தான் வருமா?
சார் சேம் வேல்யூ சார் அது.
கரெக்டா இதே எக்ஸாம்பிள் தான் எடுத்துருக்கோம் பாரு. இனிஷியல் நான் எக்ஸ்பிளைன் பண்ண இல்லையா? என்ன எடுத்திருக்கோம்? 1 0 0 எடுத்திருக்கோமா? 1 0 0 எடுத்திருக்கோமா? Okay, how do you perform exclusive or initial G2 என்ன இருக்கோ there is a B2 vandruma. Okay. Next
sir.
what happen? Next what happen? The output B2, you are going to perform exclusive OR with G1. Okay, the output are different. Okay, up now 1 hour. Here also what happen? 1 hour. So
Okay,
triple on the hour.
Okay, sir.
And what about next case, Kana? What about next case? What about next one?
1.
1.
1 0.
Super. What about next case? What about next case?
1
1.
0.
0.
0.
What about last case?
101.
Super. 101. Okay. So now what happened? I am going to successfully generate the output. Okay. This is the input. I am going to generate the respective output. Okay. If you consider the output, what happened? Okay. 3 output bits are available, namely called B2, B1. Okay. 3 output bits are available. One is called as this is the first output, output 1. Okay. This is the output 2. This is the output 3. Okay. So for that, what you are going to do? You want to designing the circuit. Okay. So how do you designing the circuit? Okay. First you look at the output. So what are the places output equal to 1? You take the respective input value. Okay. My target is nothing, but I want to designing the circuit. Okay. How do you circuit? I know the output. Okay. What are the places output equal to 1? I'm going to take the respective input values. So I'm going to form sum of minterms. So based on that, I'm going to convert it as a logic diagram. Okay, that is a target. Okay. So you are only going to tell that answer. Okay. So B2. So what happened? I'm going to designing the circuit for B2. Okay. You consider the output. What are the places output equal to 1? So, okay. These are the places output equal to 1. You take the respective input value. Okay. So this is a 1 in combination. This is second. This is third. And this is a 4. Okay. So in order to form Boolean expression, what you are going to do? Okay. You are going to take Coda map. This is a 3 variable function. Okay. This is a 3 variable function. For that, what happened? I'm going to take 3 variable Coda map. Okay. It associated with the 8 cell. Okay. And then how do you provide naming for Coda map means how the inputs are arranged in G2, G1, 0. So based on that, what happened? You take you put the variable like that. Okay, G2, G1, and G0. Okay, so you are going to fill up the values 1 0 0 1. Okay, so 1 0 0 1 0 0, and then 1 0 1 1 1 1. Okay, sorry, 1 1 0, and then 1 1 1. Okay, so now minimize the equation. What happens, sir? Okay, now you want to perform grouping. Here 8 bits are not available, so only 4 bits are available. The 4 bits are arranged in sequential manner. I can able to form quad grouping. If you minimize that, what is the answer? Anyone tell the answer? What is the answer for this one? Okay,
2.
what is the answer?
G2.
G2 alone, because G1, G0 is keep on varying. Okay. Okay. How do you do that? G1, sorry, G2, G1, G0. Okay. So this is a 1. The rest of the variable what happen? Keep on changing. If keep on changing means cancel. This is a 1. Okay. 1 dot G2. The final answer is G2. Okay. Similarly, for you tried for next case. What is the next output? The next output is B1. Okay, for that you want to designing the circuit. How do you do that? Okay, so what are the places? What are the places? The output equal to 1. So what are the places output equal to 1? You take the respective input values. You take the respective input values. Okay. Okay, this is 3 variable column. Okay, it associated with the 8 cell G2, G1, G0, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Okay, now fill up the value. What is the first value? 0, 1, 1, 0, 1, 1. Okay, next 0, 1, 0. Okay, what about next case? 1, 0, 0, 1, 0, 0. What about next case? 1, 0, 1. Okay. Okay, here octant is not possible. Next possible is quad. Quad also is not possible because the once the input values are segregated, scattered on different places. Okay, the possible grouping is pairing. This is one type of pairing. This is another type of pairing. Okay, what is the answer? This is a G1. Okay, this is a considered as a G2. So what is the final answer? Okay, G2, okay, G1 is nothing but G2, 1, G1, G0. What is the answer? 0, 0, 0, 1. What is the answer? G2, G1 bar. Okay, this is a concept. So similarly for G2, okay, how do you do that? G2 is G2, G1, G0. Okay, G2 is a fixed, G1, G0 is keep on varying. That is called as a 1, 1, 1, 0. Okay, if you minimizing it, what happen? G2 bar, G2 bar, G1. This is cancelled. So what is the final answer? So B1 is G2, G1 bar plus G2 bar, G1. Okay, it is okay for you? Okay, this is okay for you? Do you have any queries? Hello? Okay. Similarly for B2, sorry, B0. Similarly for B0. Similarly for B0. Okay. Okay, you will try it out yourself. How do you form Boolean expression for B0? Okay, you look at that output. So what are the places output equal to 1? This is 1. This is a 1. This is a 1. And then last case. Okay. So now this is a 3 variable function. So for that, what I'm going to do, I'm going to take 3 variable column 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Okay, and fill up the table. What is the first combination? 0, 0, 0, 0, 1. 0, 0, 1. What about next? 0, 1, 0, 0, 1, 0. Okay, what about next case? 1, 0, 0. Okay, what about next case? 1, 1, 1. Okay, so here what are the possible groupings are available? Here what are the possible groupings are available? Quad is not possible. Quad also not possible. Octant also not possible. Okay, because the input is the input values scattered on the different places. Pairing also not possible. Okay, okay, you should write all the midterms. Okay, what is the final value? Okay, write it down. Okay, what is the G2 bar, G1 bar, G0. Similarly, G2 bar, G1, G0 bar. Okay, next, what is the next? G2, G1 bar, G0 bar. Okay, what about next case? G2, G1, G0. Okay, if you minimize that function, what happen? It's going to generate the equation like that. So what is the name of that equation? Already we discussed that. What is the name of the equation? Anyone tell that? What is the name of the equation? So what is the name of that equation? Already we discussed that. That equation name we call it as odd function. Okay, that equation name we call it as odd function. Why it is called as odd function? Okay, these are the places output equal to 1. You take the respective input combination. Okay, odd number of ones are available. That's why it's called as odd function. Okay, do you have any queries? Okay,
No, sir.
Okay. Okay, now successfully form the Boolean expression for all the variables. Now our job is we want to draw the circuit diagram for those Boolean functions. Okay. So now successfully form Boolean expression. So what is the Boolean expression for B2? The B2 is G2. What about B1? The B1 is G2 G1 bar plus G2 G1. Okay, it's look like exclusive OR gate. I'm going to written as like that. Okay, what is the final output? The final output is odd function. That is nothing but G2 exclusive OR G1 exclusive OR G0. Okay. Okay. Or next step is we want to draw the logical diagram. Okay, we want to draw the logical diagram. Okay, how do you draw that? Okay. Okay, G2 order. Okay, G2 value. I'm going to treat it as output of B2. What about next case? G1, G2. I'm connected with exclusive OR gate. Okay, that is a final output. Okay, that is called as a B1. Okay, B1 is G2 exclusive OR of G1. So what about next case? You want to generate the B0. Okay, how do you do that? Okay, G2 plus G1. Okay, along with what happened? I'm going to add G0. Okay, this is the input for exclusive OR. This is the input for exclusive OR gate. And then it's going to generate the output is nothing but G2 G1 exclusive OR of G0. Okay, so do you have any queries? Do you have any queries? Hello.
No, sir.
Okay. The next thing is you're going to try it out yourself. I will tell you teaching. I will tell you how do you convert binary code into gray code. Okay. Okay. For that, what happen? You're going to try it out yourself. Okay. I will not work it out. Okay. Next thing is okay binary to gray code. Binary to gray code. I will tell the logic. What is the logic? G2 equal to B2 and G1 is B2 exclusive OR of B1 and G0 is B1 exclusive OR of B0. So I will take one example. Already I discussed that. I'm going to take similar example. Okay, this is I'm going to consider as a B. Okay, B. So it associated with the 3 bits. This is called as a B2, B1. This is a B0. Okay, how do you generate the respective gray code? Okay, initially B2 you consider as a G2. Next, what is the next case? We are going to perform exclusive OR between B2 and B1. Okay, similarly for B1 to B0. Okay, okay, this is a considered as a input. So based on that, you are going to draw the circle. Now what I am going to do, what you are going to do, you take three variable as a input. That is called as a, you take binary B2, B1 and B0. Okay, what is the output? The final output G2, G1, G0. Okay, you take three bit input combination. Okay, you take 3 bit input combination. Okay, so you are going to tell the answer. So what is the answer for G2? What is the answer for first combination, input combination? So what is the input for first combination? Anyone tell the answer? Anyone tell the answer? Okay, this is educated as a homework. Okay, you tried out yourself in your home. The next class beginning, I will call you, any one of you, in random order. That person, they are going to tell the answer. Okay. Okay, try it out yourself. So what is the answer for first input combination? Hello?
0, 0, 0.
Okay. 0, 0, 0. What about next case?
0, 0, 1.
0, 0, 1.
0, 1, 0.
0.
0, 1,
Okay.
1. Sir, 1,
0,
sir.
1, 1. Okay. What about
0,
next piece?
0, 1, 0.
Okay.
1,
1,
1, 0.
1, 0.
1,
Mm.
1,
1.
1.
Okay.
1, 0,
1, 0,
1.
1. Okay, what about last case?
1, 0, 0.
0, 0. Okay. So this is the input, this is the output. So what about output? The output is, you got three output. Okay, three output bits. One is called as a G2, G1, G0. Okay, already discussed that. How do you form Boolean expression for each output? Okay, you take the Gauda and then first you take the G2 and then look at that output. What are the places output equal to 1? You take the respective input combination and then fill up the Gauda map. So finally you are going to write the Boolean expression. Okay, you try it out yourself. The next class beginning, I will ask any one of them randomly. That person, they're going to tell that what is the Boolean equation for each one. Okay. Okay. Thank you so much. Do you have any queries? Do you have any queries?
No, sir.
Okay. Okay, thank you so much. If you had any queries, to be stay on online. Otherwise, you can wind up the session.